Greetings viewers, welcome to my channel. It's your ECZ examinations. In this video I'll be doing the 2023 GCE Science Paper 1, and the questions I'll be doing are questions from section B, question 4 and question 5, which one of my students requested for. Okay, the question 4 reads, figure B4.1. Okay, figure B4.1 shows a crane at a construction site raising a steel block of mass 100 kg through a vertical height of 16 meters in 20 seconds. So this is the crane lifting that block of mass 100 kg, a steel block 100 kg, a height of 16 meters, okay, from the ground. The question says 4A says calculate the Roman numeral 1 work done by the crane. Okay, calculate the work done by the crane. Then Roman numeral 2 says calculate the power developed by the crane. Okay, calculate power developed by the crane. Oh my, we already have an answer there. Anyways, I'll show you how that answer was gotten. Okay, then question B says given that the power input to the motor, the power input to the motor is 1000 watts, calculate the efficiency of the crane. Okay, so let's begin answering the question. So before we begin answering, I always advise my learners to say that in a question where the first statement that you've been given in the question, the values there you've been given are very important. Take note of them. When they've given you, for example, the quantity of mass there, expect some calculations there. Expect questions there which are requiring you to use the quantities given in the first statement. Okay, let me just zoom in for a better view. Okay, let me utilize this space here. Okay, so since we are calculating work, we already know the formula for work, right? We know that work is equal to force. Okay, work is equal to force times distance. Okay, but when we let me use a different color blue. Okay, so we know when we collect data. Okay, data. So in our data, force we haven't been given. We don't know the force. Okay, in the question we don't know the force. Distance, but the distance we've been given, the distance is what, 16 meters. So now how are we going to determine force? So physics is about knowing formulas, knowing various formulas and how to manipulate them. Okay, how to use different formulas to your advantage. So we know that force is sometimes equal to weight. Okay, force is sometimes referred to as weight. Okay, and you already know the formula for weight. So the formula for weight is the formula for weight is mass times gravity. Okay, so let's check. Do we have mass here? The mass we already know. We've been given mass, the mass of the object, which is 100 kg. Okay, it's 100 kg. And the gravity, when we're calculating weight, we know with gravity on earth is always equal to 10 grams to 10 newton per kgs. Okay, newton per kgs. Okay, so we'll proceed to say the mass which we've been given, which is 100 kgs. Okay, let me do it from here. So we will proceed to say 100 kgs. Okay, 100 kgs multiplied by 10 newton per kg. 10 newton per kg. Okay, of which the kgs will cancel and we'll be left with what? With newton, of which our weight, which is equal to force, will be equal to let me write it like this in this order. So okay, so this one was cancelled, meaning that our force, okay, which is equal to weight, will be equal to 1000 newton. Okay, that that is the force that we will use in our question. I mean in our formula for work. Okay, this formula here. Okay, this formula here. So since we've already determined the force, so meaning that we will proceed our calculations like this. So we say work is equal to the force, which we've answered to be 1000 newton, multiplied by multiplied by the distance, which is 16 meters. So this will this will give us 16,000 joules. Okay, work is calculated in. So when you're done calculating, you can write your final answer on in the answer space. Okay. Okay, let's proceed to question 2. So question 2 says calculate power. Okay, calculate power. Okay, so the formula for power developed by the crane. So the formula for power is power equal to work over time. Okay, because we define power as the rate at which work is done. So where you hear rates in the definition, where you hear rate or find the word rate, just know that time is involved. Okay, just know that time is involved. So we're measuring the rate at which work is done. So here we'll say equal to. So we've already calculated work in the previous question, and the work was 16,000 joules. Okay, so this divided by time. What is the time? Time is 20 seconds. Okay, so we cancel out the zeros, cancel one zero on top and one at the bottom. We're left with 2. Let's ignore the zeros we're left with first. Let's divide 2 into 16. So 2 into 2, that's 1. 2 into 16, that is 8. And the answer we get is 800. The units are very important, guys. Whatever quantity you are measuring, you need to state the units, because so that the examiner knows that okay, what you've calculated here is power, or is what. If you just write it like this, the first thing the examiner will ask himself is this 800, is it 800 calculators, 800 cows? Okay, so the units for power, we state them to be watts. Okay, power is measured in watts. So the same thing here. After calculating, you write your final answer in the answer space to say 800 watts. Okay, then question B. Given that the power input to the motor is 1000 watts, calculate the efficiency of the crane. Calculate the efficiency of the crane. So let me just zoom in a bit. So calculating efficiency, we use this formula. The efficiency of power, we use the formula efficiency equal to, okay, power output over power input. Okay, over power input. So what is the power input? The power input is the 800 we are from calculating in the previous question. okay, in the previous question. So what you should know, guys, is that the way the examiner brings questions, the examiner brings questions in a way that the answer the answer that you get in the previous question is likely to be used in the questions that are following. Okay, so if you get if you got the previous question wrong, and you use the same answer in the next question, meaning that that question will also be wrong. Okay, you'll get the wrong answer. So I am certain, I have absolute certainty that the answers that I've gotten from the previous questions are correct. So the power output that I'll get is 800 watts. Okay, 800 watts over, sorry, I've forgotten one thing on the formula. So this should be multiplied by 100. Okay, by 100%. Okay, because efficiency, you are looking at the percentage. Okay, you are looking at the percentage, okay, of the performance of the machine. Okay, so I'll do my calculations from down there. So I'll say 800 watts over the power input we've been told is 1000 watts. So 1000 watts. Okay, so this multiplied by 100, of which the answer that we get, we can cancel out the zeros. Okay, what we're left with is 10. So 10 into 10 into 8, that should give us something like 0 point. So if we add the 0 there, 10 into 8 will be 8, of which 8 times 100, that will give us 80%. Okay, 80%. So we can write this answer on our spacing to say the efficiency of the machine is 80%. Okay, then question 5. Question 5 reads figure 5.1. Okay, let me zoom in a bit. So figure 5.1 is a graph showing the variation of temperature, okay, in degrees Celsius with time in seconds when frozen water is heated for some time. Okay, when frozen water is heated for some time. So this is the graph. Okay, we can see it's the graph of temperature against time. Okay, and the temperature is on 100 degrees Celsius. So and then there's 0. So we can see from point A how it has risen up to B, and then at B the temperature is maintained. Temperature, I mean, um, the graph is constant there. Okay, between point B and point C. Okay, so let's look at what the question is asking. What physical change was happening to the water at the point labeled A? What physical change was happening to the water at the point A? So the physical change which was happening to the water at point A, okay, as you can see, at point A there, immediately after A, the graph starts rising. Okay, so the graph starts rising, meaning that at 0 degrees Celsius, remember this is water, it's frozen water. Okay, so at water at 0 degrees Celsius is ice. Okay, it is ice, it is solid, it is in solid state at 0 degree Celsius. So after A, the graph starts rising, meaning that at A there, the ice is melting. Okay, so that was the answer for 5A. The physical change, okay, the physical change was melting. Okay, then let's move on to B. B says, in which state is the water? In which states is the water at the point between A and B? In which state? So the states which they are looking for, they are asking they are asking you for the forms of matter. In which form of matter is do you expect water to be at 100 degrees Celsius between B and so this is the boiling point of water. Okay, 100 degrees Celsius is the boiling point of water. And you expect the water which is boiling at this point to be in what state? In a liquid state. Okay, liquid state. That was the answer for B. Okay, then C. When the temperature starts to rise, the volume initially decreases and then it increases. State the reason for this observation. State the reason for this observation. So what you should know is that uh, I don't know if you've noticed this. Okay, when water is in solid state, okay, when water becomes ice, the ice is usually bigger in size when you compare it to the water, to the same amount of ice in liquid state. Okay, this is because this is because solid ice or water ice or ice water, okay, ice water has a higher volume, okay, has a higher volume as compared to liquid water, okay, as compared to liquid water. Liquid water has a less volume, okay. And also what you have to know is that gaseous water, which is water vapor, okay, which is water vapor, uh, this vapor, this water vapor has this water vapor also has a higher volume as compared to the liquid water. So in the question, the question is saying when the temperature starts to rise, so the moment the temperature rises, you expect ice water to start melting, right, to change into liquid. So there is ice water which had a higher volume. So as the temperature rises, the volume will decrease because the ice has turned into water which has a lower volume. Okay, again, because the temperature is still high, the water will begin to boil, of which it changes into water vapor, of which the water vapor also has a higher volume as compared to liquid water. So you expect the volume from being decreased to rising again, to being high again. Okay, so this is the answer that I gave. As the temperature rises, ice water changes into liquid water. The volume of liquid water reduces because liquid water has less volume than ice water. As liquid water changes into gaseous water, the volume increases again because liquid water has less volume as compared to gaseous water. Okay, so thank you guys for tuning into this video. Thank you for being with me up to the end. If you've enjoyed the video, please like and subscribe to my channel, and also um, comment on what topic, in which subject you'd like me to help you with, in which subject you'd like me to make a video of. Okay, I'm here to help everyone from grade 8 to grade 12. And for those who'd like to contact me on WhatsApp, you can contact me on this line, 0772 92 20 70 72. Pardon me, 72. Okay, otherwise this marks the end of the video. Thank you all.